Hello world and welcome. I'm Rick, and today I'm going to be talking about keyboard mapping for the Vice family of Commodore 8-bit computer emulators. Part 2, Starting a Map File. Last time, I described my plan for creating a useful, to me, map of my MacBook's keyboard to a Commodore 64 keyboard to use in Vice, the emulator for all of Commodore's 8-bit computers. The mapping I came up with was this. Every key and PETSCII graphic character available on the C64 keyboard maps to somewhere on the Mac. Since the mapping very much keeps things in their proper place on the Mac keyboard, I should be able to type efficiently using this mapping. Now if I only knew how to actually make that mapping. The way Vice handles keyboard mapping is by using a Vice keyboard map, or VKM file. You can find many examples of these in the Vice distribution. The VKM files have all their documentation in that file itself. Well, almost all, but we'll get to that. The rest of the file was mostly mapping lines. Each of these had some key code and a few numbers following it. Occasionally there'd be a comment, though not often. It was pretty cryptic, and despite reading through the upper comment block, and even reading some of the documentation and various forum posts, it just wasn't making sense to me. I can't really say why. Then I stumbled across this video from Groundhog Graphics Retro. Suddenly things clicked for me, and I realized what I needed to do. The fact is that most of what I needed was sitting right in front of me, in that comment header block of the VKM. There are really three things that must be understood to make sense of the key mapping definitions in the file. First, key code, the keys on the host keyboard you can map from. The host keyboard is the keyboard you're typing on. These are all named, like minus, semicolon, period, and plus. Second, row and column, the matrix grid location of the key on the emulated keyboard, meaning the original Commodore keyboard. This maps to the key code. The keyboard matrix, which is different for each emulated keyboard, is in the comment header. Here are the same keys on that matrix, minus, semicolon, period, and plus. Third, and finally, shift flags. The flags to apply to this mapping, which are listed in the comment header. These apply to both the host and emulated keyboard, such as the shift keys on the Commodore 64, and the shift keys on the MacBook, or the 64's Commodore key and the Mac's option key. All of that is documented in the comment header, but I still had a couple questions. First, how do I know the key codes? I mean, yes, there are obvious key codes listed in the file itself, but what if the key I'm looking for isn't listed? Since the default VKM file is intended to work with a standard PC keyboard, there are bound to be keys on my MacBook that aren't listed in the file. Second, which shift flags do I apply? The video above gave me the clue as to how to apply shift flags, but it was going to take some experimentation to really get them straight. I did recognize that the block of definitions at the start of the file, just under the comment header, were effectively reserved code. No changes needed, or indeed recommended there. I would leave them be. These were Vice telling Vice how the Commodore 64 keyboard works. One thing I immediately saw was the organization of the default mapping file was not helping me. It is organized around the keyboard matrix. To me, that made it unhelpful for visualizing how my mappings were going to work against my target keyboard. Rather than try to fight against a file organization I wasn't fond of, I chose another route. Everything below that reserved section must go. I'll start the mapping from scratch. I wanted to organize my mapping file by the keyboard I was mapping from. In other words, my MacBook, if you somehow forgot. So I first added my own comment block showing that keyboard. Then I could begin specifying mappings row by row of that keyboard. For the Commodore 64, the keyboard is handled by a set of wires that wrap around in such a way that each key is at the intersection of two wires. Vice, being an emulator, matches the way the underlying hardware works. This forms a matrix of rows and columns, and it is these that are used to map the host keyboard to the emulated one. This mapping is reproduced in the VKM file's comment header. So to map the 0 key, on the emulated keyboard, the row will be 3 and the column will be 4. So I know what to map to, but what can I map from? Looking at the provided mapping file, I can see lines like these, one per letter. I also see lines like these, with key descriptions, but what descriptions work for each key? The answer was in the settings. You enable keyboard debugging in the status bar. Turning this on showed me the name of the host key I was pressing in the emulator. Those key names were what I needed. Now let's get mapping. The top row of keys on the MacBook are escape and the function keys. It also has the power key, but we can't map that to anything. We'll start with mapping the Mac's escape key to the Commodore 64's stop key. First step is figuring out what the key code is for that key. The key label might say ESC, but the keyboard debugger says escape with a capital E. The stop key is at row 7 and column 7. So mapping the escape key to the C64 stop key is... At this point, I realized I really didn't know what to put in for that shift flag's value, but I saw that most of the keys mapped in the default VKM file used a value of 8, and I saw that this mapped into the list of flags in the header content, so an 8 means key can be shifted or not with this key sim. As an aside, I think key sim might stand for key symbol, but I prefer to think of it as simulated key, and yes, I know that's the wrong spelling of sim. This makes it clearer that key means the key on the host or Mac keyboard, and key sim means the one on the simulated Commodore 64 keyboard. So what that means is that the host MacBook key escape will map to the C64 runstop key sim acting as stop, and the combination of shift and escape will map to shift and the runstop key, otherwise known as run, on the C64. So 8 is the correct shift flags value for this key, and the mapping is escape 778. First key mapped. Let's move on. Mapping the F1 had a small challenge on the Mac. The function keys aren't function keys unless you also press the FN key in the lower left of the keyboard. But the keyboard debugger shows that this is something happening behind the scenes. Pressing the F1 key on the keyboard will not even show up on the debugger. It will just dim the screen, which is its primary function. But pressing FN and the F1 key together shows as F1. Okay, so F1 is my key code to map. That's at row 0, column 4. So our map will be F1048. But wait, using a shift flags value of 8 means that combining shift, FN, and F1 would be interpreted as the Commodore's F2 key. And the MacBook has an F2 key, so I don't want to support both unshifted and shifted versions of F1. This means that I want to use a shift flags value of 0. Key is not shifted, making the actual mapping F1040. This will mean pressing FN and F1 on the Mac keyboard will always map to the C64's F1 key. Which brings us to how to map F2. As I said, the Mac has an F2 key. The Commodore 64 does not. F2 on the C64 is obtained by pressing Shift and the F1 key. We know how to map the MacBook key to the C64 key, F2, 04, and some shift flag. But what shift flags value should be used? In this case, a value of 1 works. Key is combined with the shift for this key sim. At this point, I admit that I had trouble parsing the descriptions of these flags. The video I cited above gave me a clue how to read these, and subsequent experimentation, which you are seeing here, got me comfortable with them. But the descriptions provided in the content header documentation is really not all that great. The mapping for F2 is F2041. In this case, pressing F2 on the Mac will always map to the C64's F1 key and Shift key simultaneously. This pattern follows through the remaining function keys, F3, F4, F5, F6, F7, and F8. The spare 4 function keys on the Mac were a good place to map a few other of the Commodore 64's special keys. I planned on mapping F9 to the restore key, but the restore key isn't on the keyboard matrix. This is where a few lines in the header come into play. These are extra row-column pairings that match up to the cases where the standard keyboard matrix does not cover the key in question. If you look at the service manual diagram, you see that the restore key is outside the keyboard matrix. So the mapping will need to be F9-3-0. Although there is no direct documentation, looking at the default VKM file showed that these special negative row mappings have no shift flags values. And with that mapping, I can get the run-stop restore sequence by pressing Escape, FN, and F9 together. The plan was to flatten the home clear key, mapping F11 to clear and F12 to home. But at least on my MacBook, F11 does something to the screen, and there's no stopping it. So I need to find an alternative approach. I could map the F10 to clear and keep F12 mapped to home, but it would be weird having that skipped key in between, so instead I will just use F12 for both. The home key is on row 6, column 3, and we can use flag 8 to make it work with and without shift. So the mapping is F12, 6, 3, 8, making F12 by itself the home key, and shift F12 becomes shift home or clear. And with that, the first line of the MacBook keyboard is mapped. Let's do a review of what was done. We started with the escape key, moved through the function keys, did restore, and home clear. This all starts filling my VKM file back in. Next up will be the second row. Thanks for watching. I hope you'll join me as we push further into building a full Vice keyboard mapping file.